Hey guys, we're back another week. Hope things are going well. Miss you guys. Can't wait till we're all back together. So hope things are going well. Hope everybody's healthy, safe in your families. Okay, now guys, we're kind of moving on from what we were doing last week, which was, remember, turning degrees into radians. Okay, which obviously, it's like, okay, that's great. What's the purpose of that? And guys, actually, the application of degrees to radians has something to do with arc length. Now, an arc means the distance around the outside of a circle. So like an arc is part of a circle. So if I did a little squiggle here, this section right here, this piece of that circle is an arc. That is an arc. And guys, there's a lot of application to this in engineering. So if I wanted to know how much distance did this, again, in engineering, guys, a lot of machinery uses wheels. You see, if you look inside your car, parents' car, whatever, you see a lot of circular things with belts on it. So the distance around the outside of a circle is really important within engineering. Now, guys, if you remember, arc length is kind of like part of circumference. Remember circumference? Okay? In geometry, remember? Circumference is all the way around the circle. Well, obviously, if I'm just doing a piece of the circle, I want to just find that little distance right there. Now, if you remember, all the way around, okay, circumference was 2 pi r. Okay? Now, I know this is going to be kind of a stretch. Okay, so r is obviously the radius. So like in this circle, right there, the radius is 6 centimeters. If you can read that. That radius is 6 centimeters. 2 pi is the whole circle. Okay, all the way around a circle is 2 pi. And guys, 2 pi is that radian measure. Okay, so if I want to know the whole circle, I could go 2 pi times 6. If I want to know the whole circle. But guys, I only want to know this little piece right here, this section of the arc. So what we actually have to do is convert that into radians. Okay, that's actually the application. To find the length of that arc right there, I'm going to take that angle. Now, if you can see, I know I'm trying to write big enough. That's 50 degrees. So guys, 50 degrees. And now if you remember, like we were just doing on that last video, I'm going to take 50 and put it over 1, okay, times pi over 180. Remember, that's how we convert degrees into radians, pi over 180. Now we're going to reduce this. Now remember, I am starting off, we're going to do another video next that make it a little bit harder, but we're kind of starting easy. Remember, you can cross off a 0 on the top and a 0 off the bottom. Now nothing else can cancel. 5 cannot go into 18, so we're actually done. So what's left on the top is 5 times pi over, 1 times 18, 5 pi over 18. But now, so I converted 50 degrees into 5 pi over 18. So that's the radian measure. But now, just like here, 2 pi is like the radian measure times the radius. So I'm going to take 5 pi over 18 times my radius to actually find the arc length. Okay, now guys, all we're going to do is put this in a calculator. Now remember, guys, on your Chromebook, if you type in Google Calculator, you can actually have a calculator on your Chromebook to do all this scientific stuff. Okay, so this is actually how you would type it in. You're going to type in 5 times, so again, pi, remember, we'll use 3.14. I think everybody knows that. 3.14. So 5 times 3.14, divide. Remember, a fraction means divide. So again, let me put this down here. So 5 times 3.14. And then, guys, remember, a fraction means divide. So divided by 18 and then times 6. I mean, that's really what we have. 5 times 3.14 divided by 18 times 6. I know that looks like a lot, but that's going to be your answer. So 5 times 3.14 divided by 18 times 6, and let me try that again. We might have to put equals in between here. So 5 times 3.14, hit equals, divided by 18 equals times 6. Let me make sure. Okay, same answer. Sweet. Okay, you can put this all in at once. So guys, you can type this all in at once, and the answer comes out 5.23. Now guys, just like we did before, we're going to round to one decimal. So 5.23. I'm going to underline the 2 because that is a 3. 5.2. Now again, our units was centimeters, and guys, that is the length of that arc right there. So if you're an engineer and you're trying to figure out, okay, how long is that arc right there? It's 5.2 centimeters. That's how long that arc is. Okay, that's what we just found, 5.2 centimeters. Okay, good. Let's try a couple more. Okay, get the hang of this. Okay, so again, just like we did before, we're trying to find the outside arc. Now, guys, look at the arrow here. So this time we're actually starting here again, but we are swinging all the way around to here. This is our arc. We're obviously they're not doing the whole circle, but we're doing a bigger piece of the circle. So that's 210 degrees. So just like we did over here, 210 over 1 times pi over 180. Remember, guys, just like we said on the last video, it's always pi over 180. Okay, now again, we can cross off the zeros. Now, this time we're not done. 21 and 18. 21 and 18, remember, we try to reduce. What can go to 21 and 18? You can divide by 3. So divide by 3. Divide by 3. 21 divided by 3 is 7. We still have pi up there. Okay, and then 18 divided by 3 is 6. So actually, this reduces to 7 pi over 6. Now times, again, our radius. 9 centimeters is our radius. So 9. Okay, and guys, we're going to type that in the calculator, and we'll have our answer. Now again, just like we said, you can just type this all in. So 7 times 3.14 divided by 6 times 9. So again, 7 times 3.14 divided by 6. Remember, fraction means divide, times 9. And hit the equals, boom. Now, obviously, guys, look, that's a long arc. That's more than halfway around, so this is much longer. Okay, if you type this in, you got 32.97. Ooh, this is a tricky one. When I round, guys, I'm underlining the 9 because it's a 7. That 9 goes up to a 10, which carries to the 32, and guess what? 33.0. That's going to be the answer. That's going to round all the way up to 33. 32.97 go all the way up to 33. Okay, last one. Now again, guys, engineering again. There's every option. So this time we're actually swinging from here all the way around. Woo! All the way around. Boom, right there. So we're actually going, you can see right here, 320 degrees. Okay, now what's nice, guys, is a lot of this is the same math. 320 over 1 times pi over 180. Okay, so 320 over 1 times pi over 180. Again, cross off the zeros. I have a 32 and an 18. Now that's one of those where, what can I go? I know that 32 and 18 are both even numbers. So I know I can divide by 2. So divide by 2, divide by 2. 32 divided by 2. Again, you probably need to do that in your calculator. 32 divided by 2, though, is 16. Okay. And let's make sure we're reviewed here. Okay, we're reduced. Okay, now I'm going to keep it because sometimes you might have to reduce maybe more than once. But 18 divided by 2 is 9. So now I got to say, okay, can anything go into 16 and 9? Nothing can go into 16 and 9. So actually, 16 pi over 9 is our answer. Okay, times, okay, there is our radius. Okay, our radius is 17 meters. So this could be some kind of, distance around a fence, 17 meters. I mean, that's pretty long. Okay, so let's say that this is like an outside fence and we're trying to find the distance around that fence. Okay, so we're going to, again, here's our number, 16 pi divided by 9 times 17. This is probably going to be a pretty big number. So 16 times 3.14 divided by 9 times 17. And yeah, this is a big number. You're getting 94.89. Again, underline the 8 because that's got a 9 next to it. Actually, 94.9 meters. Okay? So again, if this was, again, a fence you had to put in around something, maybe this is the doorway, okay, you're going to need 94.9 meters of fence to build this circular enclosed area. Okay, so again, this is all application things that you can do in engineering, okay? Now, just take a look here, do your best, okay? Whoop, I don't want to get the shadow in there. Okay, hopefully you can see all those numbers there. Okay, we got 160 degrees and a 5 centimeter radius. Okay, the other one is 200 degrees and a 12 meter radius. Okay, so go ahead and find the arc length that we were just doing for those two, okay, and stick them into the journal entry, okay? Thanks, guys. Take care. Bye.